Yeah, welcome. I'm going to tell you something about TypeScript. Actually, I'm a backend developer by what's the word? By it's my background, and I've become quite enamored of TypeScript and its features, and I think it has something to offer for traditional browser developers as well as traditional server developers. So that's what I'm going to report on. I work for Codestar, which is a unit of Ordina Netherlands, as you may know. Yeah, so my background, programming in Scala, functional programming, reactive programming. So the talk by Stefan was incredibly interesting for me. Of course, the implementations of reactive streams that I know are Akka streams and S-Wave and stuff like that. And of course, RX. Um, worrying about Docker stuff and clusters and all that how to store the data and transactions. But so, browser development wasn't my world, I'd say. And for the last year, so why would you be interested in what I have to say on TypeScript, right? For the last year, I've been building a build tool for TypeScript where you get an integrated continuous compilation for Scala on the server side and TypeScript code on the browser side. And so I've been doing a lot of digging around in the code of the compiler itself, which is implemented in TypeScript, obviously. And I've been working on a few projects in TypeScript with Angular 2 and RX. And the most recent one in Angular 2, the previous one in Angular 1. So that's my experience. I've been working with TypeScript for a year, full time basically. So yeah, what is it? Behold the splendor of TypeScript. It's amazing, right? So this is JavaScript. Actually, all JavaScript by default is already valid TypeScript. They add extra features, so that's why they say it's a superset. But already, if you take your JavaScript code and start compiling it with a TypeScript compiler, you get something for free. Basically, I'm using my object. I get warnings, I get drop-down code completion suggestions. The red C points out that I've been typing something wrong. So, when we talk a lot about types and that they're so cool, etc., this is why they're cool, right? Because your text editor, your IDE, is able to immediately give you feedback. Hey, there's something fishy going on here. So keep that in mind. They're there to help you, and that's especially helpful if you are writing a lot of code. Obviously. Well, we're getting. I got the question, what IDE is that? Actually, there are a lot of editors and IDEs that all have exactly the same support. I'll get into that later if you don't mind. So it's JavaScript, but it's smarter. And I want to tell you something about in what way it's smarter. I told you, you get immediate feedback, what I call the red C, the crinkles saying there's something wrong here. You get code completion. You can click through to the definition of a function, of a class, stuff like that, which is incredibly helpful, right? When you have a huge code base, you're joining a team. Hey, what's going on here? What calling are we calling here? Oh, okay. So what's that calling? So you can browse through this big code base. That's all made possible by types and the compiler helping the editor or the IDE. And then, of course, refactoring with confidence. if you have a bigger, I don't know if you ever had the paralysis of, you have a big code base, you didn't write it yourself, you need to change something. Whoa, what's going to break? And types are awesome that way because they point out, hey, here it breaks, here it breaks, here it breaks, here it breaks, and you can start. In the best case, actually, you change stuff and it just works. Really, in some cases, you really can achieve that. So it's all the compiler doing this with types and something called type inferencing. If you've done any Java writing, you know that you have to write down all the types yourself, right? Well, not in lambdas. That's a bit cumbersome, and so maybe people feel it's just what's the word? Too much work. And with type inferencing, basically, the compiler can work it out himself. And that's what you see in all the modern languages, actually. Whether it's Swift or Scala or Typescript, they all have type inferencing, and it's awesome. It's I'd say it's the perfect middle ground between the ease of untyped, well, actually dynamically typed programming, and the security of statically typed programming, I'd argue. Is this readable, the code? So I'm going to use a lot of code. I hope that's okay with you. The types in TypeScript, right? You have some simple greeter function, and I have to scroll back. So you see we're calling it with an object literal, and we didn't use camel case for the last name property. It's stupid, but I've run into this, and it's nice if you see it immediately, instead of having to deploy your application, browse through stuff, and then see, oh wait, there's something missing here. So that's what you get interfaces in TypeScript on top of your normal JavaScript. They only are available at compile time, and at runtime they're not there anymore, as you'd expect, right? So you start out. One of the things I really like is you can start out with JavaScript code, either because you have an existing system, or you're using an existing library, or you found some solution on Stack Overflow, and you need to start out with that and refactor it into the kind of code you want, and that's super powerful. And then you can start ruling out error-prone patterns. First by adding types, obviously, and second, you can. There are some extra features that help you detect in the TypeScript compiler that help you detect error-prone patterns. And well, JavaScript used to have a lot of them, right? That's what it's well known for. So this makes TypeScript a really pragmatic, useful language with which you can get started basically tomorrow on your project if you want to. So I mentioned ruling out error-prone patterns. There are some flags in the TypeScript compiler that are incredibly powerful. I won't enumerate all of them, but for instance, in a switch, you can have by default a fall through, and then at runtime, you'll find out that it doesn't do what you expected. That's a well-known gotcha. Another one is that you think that you're using a this reference, and then you find out that in the JavaScript world, this is the caller and not you yourself, the code being called. And that's so there are a lot of stuff here that helps you rule that out, but you can start out with plain JavaScript and it will accept it. Actually, even if your code doesn't compile, it will emit valid JavaScript. And that's exactly for the same, what's the word? for the same reason, because maybe you start out with an existing code base. That's incredibly uncommon in compilers, actually. It's not the academical mindset, I guess. So one of the important things is that TypeScript builds on ECMAScript 6. So and it compiles it down to ECMAScript 3 or 5. So basically, what that means is you can have the niceties of the future ECMAScript versions while your code runs. You know, there's always a browser lagging, or you know, God forbid, your code has to run on smartphones, right? Because they often only support ECMAScript 3, and yeah, so it builds on that. This is some ECMAScript 6 code. So you see some imports on the top of the file. If you come from a server-side world, you say, okay, yeah, so. But in the browser, there was nothing like this. And actually, in the background, this is compiled down to asynchronous module loaders that get everything asynchronously from the server, your requirements. And this actually is some React code. And you see that it adds an interface and makes the function down here typed. So that's another point. You can use TypeScript actually for anything that you want to develop in JavaScript. And there's really good React support, but yeah, basically anything, Node or Ember, or you know, whatever your fancy is. Yeah, so let's see, start gradually and yeah, add more control until you feel, you know, this is my perfect balance. So this is some, you know, some well-known code. You have something about cards and suits, you know, clubs and hearts, and you have a function that needs to pick a card. So this is standard JavaScript. And you see that the pick card, yeah, just receives something. And so if we want to add some types, here I'm using quite a lot of features. So first, when we look down towards the pick card function, we see that it either the X that it accepts is either a deck or a rank. This is something that happens a lot in JavaScript, so the type system needs to deal with this. We've defined a deck as an array of cards, and card is an interface, and suit, for instance, is a type alias, which is basically a shorthand for the type on the right-hand side, which is just an either this, the literal string hearts, or spades, or clubs, or diamonds. This is really powerful, but hopefully you'll see that later on. Not a lot of programming languages can deal with literal types at the moment. And it basically means that the compiler knows which strings you accept. And of course, all our programs, what's the word, are crawling with enumerations. And that's a perfect pattern for that. So the title of my presentation is Enjoying Large-Scale Browser Development, and that implies something, right? That I didn't enjoy it. So this is a little bit out of my weepy diary, the sadness of JavaScript. So take it for what it's worth. It's from the perspective of a server-side developer, right? So this is the prime one, I'd say. Uncalled type error, undefined is not a function. Okay, well, thank you for telling me. So if you go on Stack Overflow, you know, it's everywhere, right? And so this is a really important one. Actually, this is a problem that is solved by TypeScript. I'll go into that later on. Basically, it helps you rule out that something is null or undefined. Really powerful stuff. This is another well-known one. There's a notion of truthiness in JavaScript, and if you do use the standard double equals check, it will, it will make a best effort, I'd say, and especially the values that light up outside of the diagonal are the unexpected ones. And then, does anybody know what this is? It's I'd say that, yeah, front-end developers. Yeah, we have them. So I'll repeat the immediately invoked function expression. So we define a function, and at the end, can I point with this? I guess not. Okay. Yeah. So this is the function. And then here at the end, we immediately apply it with a value that will be given to it here. So, if you're a seasoned developer, you've got the brain power eventually to recognize this pattern, right? But it's a bit verbose, I'd say. This is called the module pattern. Basically, you use a function to create a closure with data and functions together, an object. Actually, this one models classes and inheritance. Actually, it's the output of the TypeScript compiler from this code. And for a lot of people, this is very intuitive, right? This is C#, Java. It's classes, inheritance. So that's nice, I'd say. That's ECMAScript 6 for you, being transpiled down to JavaScript 5. Makes me happy. A little bit more about the sadness of the JavaScript experience. To be honest, this is from 2008. It's the book JavaScript The Good Parts, I think by Crockford, I think. And it contains an enumeration of the awful parts of JavaScript. It's meant as a list of thou shalt not. I've right next to it, I've put the things that exist right now that help you rule out these things out of your huge code base if you're banging away with a few teams. So we have all the tools to rule these things out. Similarly, the bad parts. So if you use tslint or eslint, it will tell you don't use the double equals, use triple equals. So we've been on a journey away from the bad parts of JavaScript. Module loaders, linters like jshint, eslint, tslint, the ECMAScript updates, ES6, and now types. So that's my point. Basically, types are the next step in the browser world. Yeah, what? Hey, something goes wrong with my slides here, I think. Okay, well, I guess we get to the beer faster. Sorry about that. So I explained about the features in ECMAScript 6. Maybe if we have time, I'll get around to that. A little bit more about being smarter about JavaScript. These are some of the things that are incredibly common in the JavaScript world. I, as a server-side developer, felt, was reeling for a moment. What are they doing here? So, for instance, in functions, it's really common to, all arguments are optional. So, you have to expect the unexpected, I guess, and you just check, did I receive something, and then, you do something, this is code, and if it didn't feel so uncontrolled, maybe it's perfectly fine. The way to do that in TypeScript is you can add a question mark to the argument, and that basically says, dear compiler, this one is optional, so they don't need to provide a value, or they can provide undefined. But for the other ones, they are required. So please check all the calling code that they provide a value, which makes me, you know, heave a sigh of relief. So my anxiety went down. Actually, the if statement is a so-called type guard. So at the beginning of the function, the type of last name is string or undefined. That's the whole type. And after the check, if last name, it's actually string. So the compiler will tell you if you've done the necessary checks in your logic. So this is also a pattern that you see often. I'm not sure it's perfectly obvious from just gazing at it briefly, but actually this function takes either a single string or an array of string, which is very accommodating, I guess, but feels a bit strange from a server-side development perspective. And similarly, there you can define a type alias string or string array, and then again the compiler will trace through the implementation of your function. Here it still can be both cases, and at this point you did your work of checking what cases is, and you can safely invoke the length function or join in this case. So that's really nice. Actually, they're called union types, which is a bit academic, I guess. So I think the name or types is more intuitive. So using TypeScript, it's always very nice if you have a perfectly elegant language, but if there aren't the tools, what use is it? So this was your question. Actually, the editor that I showed is called VS Code, Visual Code. Obviously, it what's the word? Borrows a lot from editors like Atom and Sublime. But all of them have great TypeScript support, and that's because the TypeScript compiler actually provides an API for code completion, refactoring, go-to definition, and all that stuff. And that's really awesome because all of them have the same perfect support at any time that a new version of TypeScript comes out. I think that's really clever. And basically it means that the difference between an IDE and a text editor fades away, right? Just to, I told you that types help you navigate a code base. So let's have a peek at the API that the compiler offers. It's called the language service. And so if we want to know the code completions, we're somewhere in our code and we wait for the suggestions. It's the function getCompletions at position. And we can just click through, okay, but completion info, what's that? So a list of some possibilities, I guess, completion entries, a name, kind, the type, etc. Is it public? Is it private? So this is incredibly familiar for server-side developers, but now it's available on the browser side as well. And personally, I find this incredibly helpful in big projects. So for the people who are very familiar with typed programming, people who work with Scala and Java and C# and stuff like that, these are some of the features that are not available in those languages yet. So, or at least some of them not yet. One of them is union types, as I mentioned previously. I'll show you how this is an interesting example of union types where we have birds who can fly and lay eggs, and we have fish who can swim and lay eggs. They have nothing in common that that means that they can lay eggs, right? It's a bit of a coincidence in evolution, I think. And so we have a function get small pet, and the interesting thing is we can even before we check which case did we receive, we can already invoke the lay eggs function, because the compiler works out, you know, all cases in this union support this common type, basically. So that sounds a bit like duck typing, right? If it lay eggs, can lay eggs, it must be a fish or duck typing. Familiar? So it's the opposite of what we do at Java world or Scala world, where things have a name. And duck typing is, you know, if it has, if it quacks, it must be a duck. Yeah, so you know, if it has a lay eggs function, well, you know, then it's in this case a fish or bird. A little bit more about TypeScript types. So this is a bit more for the types aficionados, I'd say, people who like all the intricate things about types. TypeScript types are actually, so we have an animal that has an attribute feet, which is a number, and size is also feet with a number. Obviously, they mean different things, right? But we can assign a value of each to an argument of the other. And that's because they have the same attributes, which means that they are basically, for all intents and purposes, the same. So this is called structural typing, where all the other languages I mentioned have nominal typing. It's but you know, it's a bit unexpected from my perspective, but in a JavaScript world where, you know, everything works that way, this is super useful, I'd say. Okay, this is actually something that I've teased my Scala colleagues about, you know, that Nana, your language doesn't support this yet. So this is a combination of union types and literal types, which basically means that you can define very easily enumerations that your API supports, and they're all checked at compile time by the compiler. So this is some kind of UI element that has some options of something I don't know, which is called easing. This is actual code, actually, and so if we, you know, I'm not a UI guy, so I hand it something called uneasy, and the compiler knows, you know, that's not a value, valid value for this this type. This is extremely practical in your code, I find. So this is actually something that TypeScript has borrowed from the OCaml world. Has anybody heard of flow type? I'll get into it later on. It's from Facebook, and it's what is often used with React, actually. And the guys who built that have built it in OCaml, and OCaml is all about control flow analysis. And what that basically means is that they go through the control flow of your implementation of a function, and they work out what types remain. So if we return early so we start out with a string or number, and if we return early in the case that it's a number, the compiler works out that only it must be a string afterwards. In this case, this seems trivial, right? But it works however deep your logic is. So that's extremely powerful. And then Does anybody know the $1 billion mistake? Tony Hoare came up with null, and then the joke is about JavaScript that they made the mistake twice because they have null and undefined. Actually, this helps you rule this out. I come from the Scala world, and there you often work with an option of something, and before getting to the let's say option of string number in this case, and you know you can't get at the value of the number directly until you've dealt with the case that it can be none. That's quite convoluted actually, and you know this is I'd say this is much easier. So you just see in the type either you get a number or you get undefined, and which is you know for if you're parsing stuff, something that you get very often, right? And if we have an argument that must be have a type of number, and we assign the result of our parse number function, it says, you know, you're missing something here. This only is ruled out with a specific compiler argument, strict null checks, because obviously if you take existing code, it will be riddled, and this is really the case. I've done it with a project of mine. There will be a lot of these cases, and you'll have to work them out gradually. But then you'll. This is really my experience in the Scala world. If you use everywhere where something might be not available, it's a bit of a hassle to write your code because you have to deal with all these cases. But you know, I never have a null pointer exception anymore. It really works that way. And this is much more elegant. So this is incredibly cool. For the language, the people who really are about functional programming, there's something called algebraic data types, which is quite a bit of a mouthful, but it's really powerful way of dealing with values and being able to pick them apart and have their types available. That's called pattern matching, and it's what you're doing all the time in Scala, for instance, when you're writing your code. And they support it in this way. So the challenge is in the JavaScript world, the types are at runtime not available, right? And they use the literal types. So there's these are we have a square with a kind parameter and with string literal, and the rectangle has the same. And then when we do a switch, the compiler knows in the case of square what the functions are that are available. This is something that you do in React all the time with the Redux pattern. You have a huge switch case where all your, I'd say, action objects go through. And hopefully you still remember what the attributes are of your action objects. And well, here the compiler checks it for you. So nothing is perfect, right? When not to use TypeScript. Well, if you like this stuff, this is Elm, by the way, which is really cool. And it borrows quite a lot of Haskell, I'd say. So it's purely functional, no mutable state. It works with some version of observables. If you like more purely functional programming, you shouldn't work with TypeScript because it builds on JavaScript, right? So there's mutable code everywhere if you want to. And here are some of the alternatives. I'd say the strongest alternatives is the combination of Babel and flow type. I mentioned it previously. This has been developed by Facebook, and they use it. It's almost always used together with React, and basically it does a lot of the similar things to TypeScript. I'll go into some of the differences later on. Then you have CoffeeScript, which is one of the oldest solutions for this space, I'd say. Scala JS, obviously, and some of the more purely functional things. And then recently I found out that you can compile Java down to JavaScript, which, I guess, well, all languages at the now are compiling to JavaScript, I think, right? A comparison between TypeScript and FlowType, because they're both pretty good. I'd say that TypeScript has better editor support because of this language service that I showed you, and the integration with text editors and IDEs. And actually, it's Microsoft, but it's more open development than Flow. Flow basically does a drop of their code every month, and with TypeScript, everything is on GitHub. All the design decisions are going on in the open, and they're incredibly productive, actually. For the people who have studied computer science, on the Flow side, it says it has a sound type system. Well, for the academic language designers, that's a must-have, right? So that must mean that TypeScript sucks because it has an unsound type system. Well, actually, it's a conscious decision, because they think that by letting go some of the finer, very I'd say elaborate type controls, they make it easier to use. And yeah, that's an interesting design decision, actually. And the control flow analysis TypeScript has added recently. It's something that FlowType was ahead of the game. Similarly, null and undefined aware types, tagged unions. So basically, TypeScript 2 has played catch up with FlowType. Yeah, don't use it. This is really old, right? I think, this is more than 10 years old. Some people just don't want to work with Microsoft stuff. Yeah, I'm a JVM developer on Linux and stuff like that. Personally, I feel this is not the Microsoft of Steve Ballmer. With Satya Nadella, it's a totally different. But whatever. If you don't want to, don't use it. And so these are the things I mentioned, and especially the use case is if you have a bigger team, if you have a lot of code. So if it's if it's not that, maybe don't go through the hassle of setting up your compiler and getting all the types and stuff. So to wrap up, the JavaScript of your grandfather is not what it is currently. They've made huge strides, and ECMAScript 6 and 7 are really nice. You can use it right now. It will help you, especially with bigger teams and a bigger code base. Start out with existing JavaScript code and existing libraries, lots of tool support, lots of resources online. So pretty cool. On GitHub, actually, currently it's in the top 15 of popular languages. And it has a growth of, it has grown 3.5 times in this year. So it's just under Swift, which is pretty impressive. Some resources to get you started. There's a lot out there. I want to point out one thing that's really fun to play with. The second link. There's a because the TypeScript compiler is implemented in TypeScript itself, it's just running in your browser, and you start writing. You start out with some examples. You start fiddling with them, and you see all the the Red Sea crinkles, there's something wrong here. And it's a really fun way of trying out the code and seeing what it generates at the same time. Okay, yeah, thank you. Any questions? Or are we eager for the beer? What? Yeah, is there any feedback support, you say? Debug support. Um, that's an interesting question. Well, actually, when you use source maps and you're debugging in your browser, you know source maps? Basically, it means that the compiler, if you ask it to, will provide files that show the mapping between the JavaScript that's been generated and the original code. And then if you configure your server correctly, in the browser you just can click through the, when you're debugging it, you'll see the original TypeScript code. No? Yeah? Yeah, interesting question. I might have paid you for this. So the question is TypeScript integration with SBT. Does that enable you to integrate TypeScript with the Play framework, right? Yeah, so that's the reason I made it. So I'm a Scala and Play developer on the server side, and I like to program in TypeScript in the browser. And when I start out with a project, I don't want the hassle of dealing with multiple build definitions and versioning of browser side and server side. Um, I want to be one thing. And so you get continuous compilation in Play and of your TypeScript code at the same time. Yeah, so try it out, I'd say. It's on my GitHub page, and if you pull requests are welcome. Yeah. So the question was, can you compile all JavaScript code with TypeScript, or are there things that break? Depends on what you mean with break. So yeah, it is, and that's pretty impressive because they say that even if they see obvious, well, from a type perspective, obvious. So you start out with some JavaScript code, right? And yeah, the compiler will compile it for you as is, and then the compiler sees, you're invoking here something that can't be there at runtime. It will still, if you configure it that way, it will still emit the JavaScript, the matching JavaScript code. So I can't think of a case where you can't go ahead with it. Yeah, beer. Thank you.